Hello everyone, and welcome to episode 11 of shRobot. If you're new here, I'm building my own companion robot completely from scratch. I design the parts myself, model them, 3D print them, assemble the electronics, and write all the code. So in this episode, I continue working on the robot's movement system. I printed a new improved version of the Boomerang frame. This is the main structure where the wheels are mounted. I assembled it, installed the motor, added a belt drive, and started testing the whole system. At the same time, I redesigned the frame mounting system, so I also had to print a new version of the robot's body. Now the frame is mounted differently, and the whole construction feels cleaner and more reliable. By the way, the new filament turned out to be extremely strong, so strong that even removing supports became difficult. If you have any tips on how to tune this better, let me know in the comments. I also installed a head printed from black filament. At first, I thought the whole robot would be a single color, but I actually liked the combination of the dark head and gray body. Maybe I'll keep it this way. After assembling everything, I mounted the new frame onto the body. As you can see, the frame itself doesn't fully rotate. It only tilts by a small angle. And overall, it already looks pretty decent. I think this is a good direction to continue with. The belt drive turned out to be not very reliable. The belt keeps slipping off, and the motor itself spins way too fast and makes a lot of noise. So I decided to try a different approach, building a gearbox directly inside the frame using gears. The idea is simple. The first gear spins fast, while the last one spins slower but with much higher torque. I found an example of this kind of gearbox layout and started modeling the parts. Then I printed new components, gears, and another version of the Boomerang frame designed for the new system. In the end, I assembled the second frame and mounted it onto the robot. Right now, the robot has two different movement systems installed at the same time. One frame with a belt drive and another one using gears. I intentionally kept both versions so I could compare them in real tests and understand which solution works better. I also slightly increased the wheel size to make the robot a bit taller. This should help it tilt more effectively. By the way, someone suggested trying to print some parts without supports. So special thanks to Basamfarag8092 for the advice and support for the channel. But in this version of the design, the larger wheels still required supports for now. I also installed the battery holders inside the body, which I removed from the old version of the robot. Now I'm curious to see how everything will fit inside the new body. So yes, the gear-based system turned out to be a bit more reliable than the belt-driven version, The construction became slightly more complicated, but at least now the belt no longer keeps slipping off during operation. Overall, it already feels more stable, but I still haven't solved the main problem. Everything is still way too noisy. The wheels spin too fast, so the robot mostly slips in place and creates a huge amount of noise. And honestly, I'm still not very happy with the result. But when I mounted both frames onto the sides of the body and saw everything moving together, overall, it actually looked pretty good. I probably won't change the frame mechanics too much anymore. I think this direction makes sense, but in the end, I came to the conclusion that instead of trying to push these motors to their limits, it would probably make more sense to order proper geared motors. Right now, I'm waiting for new motors from AliExpress. Low RPM motors with high torque. Hopefully, this will make the movement smoother, quieter, and easier to control. And as always, if you have any ideas or suggestions, leave them in the comments. Maybe I'm doing something wrong or overlooking something obvious. Anyway, thanks for watching. Don't forget to subscribe, leave a like, and follow the future updates of shRobot. There's still a lot of work ahead.